In the vast canvas of space, time itself seems to lose its grip. Here, amidst the twinkling tapestry of distant stars, time stretches into an unfathomable realm where light dances freely and galaxies spin their eternal tales. This is the realm where the laws of physics unfurl their most profound mysteries, where the boundaries of human understanding are challenged like never before. And there, in the heart of this cosmic ballet, lies the question that has captivated minds for millennia, the ultimate frontier of speed, the speed of light. You've probably heard Billie Eilish's song about it. The speed of light, approximately 186,000 miles per second. It's a constant, a cornerstone of our universe, the fastest thing imaginable. Nothing, absolutely nothing, can outrun it or can it. As much as we've come to understand this universal constant, it continues to confound and inspire wonder. In this video, we're going to dive deep into the enigma of the speed of light, exploring its profound implications and the tantalizing possibilities that lie beyond. Something we launched in 1977 is now outside our solar system, a probe the size of a small car, rolling endlessly through the dark. For nearly 5 decades, it has been traveling farther and farther away, a tiny human-made island against an ocean of emptiness. That probe is Voyager 1. It carries with it a record of who we are, golden discs etched with sounds and music and greetings from Earth, an offering to the cosmos in case anyone, or anything, should ever stumble across it. But Voyager's greatest gift to us may not be what it carries outward. It's the mirror it holds up to our own smallness. Right now, Voyager 1 is racing at around 38,000 miles per hour. That's fast enough to circle the Earth in about 40 minutes. And yet, even at that blistering pace, it has only reached the edge of our neighborhood. Voyager is now some 15 billion miles away in interstellar space. But compared to the distances beyond, that's barely the driveway outside our house. Naturally, we ask, can we go farther? Could we ever reach another star? Our nearest stellar neighbor is Alpha Centauri, about 4.3 light-years away. On a clear night, it looks close enough to touch, but in human units, it's 25.7 trillion miles. At Voyager's speed, crossing that gulf would take about 77,000 years. Not a weekend trip, not a single lifetime, not even the lifespan of a civilization. That's thousands upon thousands of generations of human beings. 77,000 years ago, Earth itself was a very different place. Humanity was fragile then, recovering perhaps from a volcanic winter caused by the eruption of Toba in Indonesia, a catastrophe so great it may have nearly erased us. Voyager reminds us of this perspective. When we imagine travel to the stars, we aren't only imagining machinery, we're imagining time itself, immense, humbling spans of it. Suppose we built a generation ship, a self-sustaining vessel where humans live, age, reproduce, and die, and their children continue the journey. At Voyager's speed, that would mean thousands of generations, born and buried inside a single ship, carrying the torch of a mission their ancestors began. 3, maybe 4,000 generations in all. But here's the irony. By the time such a vessel arrived, Earth might already have invented something better. Technology rarely stands still. What takes millennia today could be outdated tomorrow. Launching too soon risks creating an obsolete ark drifting through space, surpassed by faster ships that overtake it centuries later. So what about faster travel? Physicists often talk about a dream milestone, 0.1 c, 10% the speed of light. At that pace, Alpha Centauri drops from 77,000 years to just 44 years. Suddenly, interstellar travel shrinks from a myth to a human lifetime. It's still monumental. A 44-year mission demands staggering resources, life support for decades, radiation shielding, protection from micrometeors, and the will to commit a crew to a journey they may never return from. But for the first time, the stars feel possible. Of course, We can't get anywhere near 0.1 C with today's rockets. Chemical propulsion, the kind that took us to the moon, is barely enough to escape Earth's gravity well. To reach interstellar speeds, we'd need breakthroughs, fusion drives, harnessing the power of the stars themselves, massive laser arrays pushing lightweight sails across the void, or antimatter propulsion if we could ever learn to produce and store it safely. And then there's the speculative frontier. Warp bubbles, wormholes, shortcuts through space-time. Ideas that collapse centuries into moments. For now, they live in equations and imagination. But one day, who knows? That leaves us with two honest truths. Space is incomprehensibly large, and our ingenuity is the only bridge across it. But here's the deeper question. Should we even go? Would you commit to a 40-year voyage, knowing you may never return? Would you place your children on a ship that may become their permanent home? Or should we continue sending probes, telescopes, and AI explorers, eyes and ears in the void, while humanity remains here on the blue planet that sustains us? And even without setting foot beyond the stars, the hunt for life continues. Statistically, it's almost inevitable that life exists elsewhere. With billions of stars and planets in our galaxy alone, how could we truly be alone? One signal, one microbe, one undeniable trace of life, and everything changes. Without leaving Earth, we could still learn that we are not unique. Which begs the question, is exploration really about boots on alien soil? Or is it about knowing what's out there at all? So where does all this leave us? With awe, with humility, with the reminder that we inhabit only a sliver of time and space, and yet, we reach beyond it. Voyager 1, drifting farther into the dark, whispers this truth. We are small, but we are curious. And curiosity is the first step to the stars. So I'll leave you with a choice. If you had the power, would you fund a centuries-long generation ship today? Would you pour energy into faster propulsion and dream of a 44-year trip? Or would you keep humanity grounded, probing the galaxy with machines while we tend to Earth? Tell me in the comments below, because the future of exploration isn't just about technology. It's about the story we choose to write together. Thank you so much for watching.